Flashing now in your screen is the problem. We need to determine the magnitude of the vector sum v is equal to v sub 1 plus v sub 2 and the angle of theta x, which makes vector v with the positive x-axis. We have a given graph or free body diagram flashing now in your screen, and let A be the 4 units and B be the 3 units. It is located here, or the forming forming triangle part of the vector 2. 4 run and 3 units rise. And first is we need to find the hypotenuse, which is C, and our C is the sum of the squares, and we need to square root of it. 4 squared plus 3 squared is equal to 5. Next is we need to find the x component of vector 2, which is its magnitude multiplied by cosine theta x. Since cosine theta x is equal to adjacent over hypotenuse, so the magnitude of the vector 2 multiplied by adjacent, which is here 4 units, and the hypotenuse 5, and what we have here is positive 8 units. Next is we need to get the vector 2 y component, its magnitude times the sine theta x, same also 10 units, multiplied by its opposite over 5 for the hypotenuse, 5 and 3 units, and what we have here is positive 6 units. Next part is we need to find the v sub 1, or the vector 1 x component will be the magnitude of it times the cosine theta, so its magnitude is 12 times cosine 120. Why 120? Because the angle in the graph makes a 120 degree angle from the positive x-axis, and there is a given here which is 60 degrees, and if we minus 180 degrees to 60 degrees, we will have 120 degrees. Continuing, if we solve this, we got negative 6 units, since the angle is directed to the negative direction of the x-axis. Next is the vector 1 y component is equal to vector 1 magnitude times the sine theta, same also 12 units, sine 120, and what we have here is positive 10 units because it is going upward, or the vector is going upward. Next is we need to find the vector sum with the given formula v is equal to v1 plus v2. So now we have the components of the vector 1 and vector 2, so what we are going to do is to add them. So since v1 since vector 1 we have the x and y component, we can use the we can input or substitute its values. So negative 6 I hat. For this video, we are going to use the I and j for y axis, I for x axis, plus 10 units j, plus the x and y components of vector 2, which is 8i plus 6j, and combining the same terms, and what we got here is 2i plus 16j. If we are going to solve this or find the magnitude of v, so the magnitude of v is the square root of this units, so 2 squared plus 16 squared, and we got 16 units. Next is we need to find the theta x. To find theta x, we can use the inverse tangent and input the y-axis, y component of the vector or the vector sum. So our y-axis here is 16 divided by 2. 2 is our x component, and if we are going to solve this, we got 83 degrees approximate. Our next problem: the resultant of the certain system of forces has a x and y components shown in the figure below, or flashing now in your screen. Calculate the components of this resultant with respect to n and t axis rotated 30 degrees counterclockwise relative to x and y axis. So now we have a given here flashing on your screen. First is we need to find the magnitude of the resultant, or it is not indicated there, but we are going to find it. R. So what we have here is the Ry. The given is Ry is equal to 48, 480 pounds, and Rx is equal to 300 pounds. And next is we need to add them, their squares, and square root of it. So this will be 480 squared plus 300 squared. What we have here is the resultant magnitude, which is 566 pounds. Now we have the 566 pounds. Is we need to find the angle of the resultant. So the resultant angle is, no. So the resultant angle is tangent, inverse tangent. We need to input the y component of the resultant, which is 480, divided by 300 x component. What we have here is 57.99 degrees, or 58 degrees approximate. And since I use this, so let's use the 57.99 degrees in resultant direction. Next is we need to find the angle rotated, we need to relate the angle to n and t axis rotated counterclockwise. So this will be theta n is equal to n, because it is in terms of the n axis. So this will be 57.99 degrees minus 30 degrees, the counterclockwise rotation. And what we have here is 27.99 degrees in terms of n axis. Next is we need to find the resultants components in terms of n, and what we have here is the magnitude of the resultant. So magnitude of the resultant is equal to 566 pounds. Since n is related to x axis, we can use the cosine, and what we have, the angle here is 27.99 or 28, depends. What we have here is 500 pounds. So this will be the n component of the resultant, 500 pounds. And next is we need to find the t-axis resultant's component. So again, the magnitude 166 pounds times sine 27.99. If we are going to solve this, but we got 266 pounds. And that's the final answer. Thank you. So for our last problem, we need to find a unit vector that is perpendicular to both vector A and B, where A is equal to 5i hat minus 2j hat plus 2k hat feet, and B is equal to negative 3i hat plus 2j hat and 4k hat feet. So our given here is 5i minus 2j plus 2k, and B is equal to negative 3i plus 2j plus 4k. Both of them are feet unit. And next is we need to find its unit vector. Since in the problem it is indicated that it is perpendicular to both vector a and b, from its definition we can use the a cross b, and it is equal to um, using this we can find the x and x y z component of the perpendicular vector to these two vectors. So we can also use c vector as the perpendicular vector. So this will be cx, x component of the c vector or the perpendicular vector. So if we are going to solve, we can use this -2 here times 4 here and minus 2 times 2, and we can have -12 for the cx component. And next is the y component. We have here is 2 times -3 minus 5 times 4 is equal to -26. For the z component of c, 5 times 2 minus 2 minus -2 times -3. We have here is 4. And actually we have a pattern here, and we can use this matrix. It's like this: a, b, I, j, and k. So we need to input these values here: 5, -2, 2, -3, 2, 4. So why we got this is why we got the cx values here is from here. We can create a line here, or we can box this, or this part, this, or cross here. And for the y component, we can use these values, and y component, this will be 2 negative here, these numbers here, this will be multiplied: -3 and 2 and 5 and 4. So for the z component, and we can use this part, this, just like 5 times 2 minus -2 times 3. Okay, that's it. Now we have created c vector. This will be -12i minus 26j plus 4k, and our unit here is feet squared. And next is we are going to this is feet, no, not feet squared, feet. And next is we're going to find the unit vector, but before that we need to find the magnitude of it. So the magnitude of the c vector is to find the squares of these values and add them, and square root of them. So negative 12 squared, negative 12 squared plus -26 squared plus 4 squared, and its magnitude is 29 feet. So now we have 29 feet, 29 feet. To find the unit vector, we need to input first this equation: -12i minus 26j plus 4k divided by the magnitude of c. So divided by the magnitude of c is 29. So each of them will be divided, and what we have here is -0.4i minus 0.9j plus 0.4 Okay, units, because what we have here is feet and feet. If we divide here, it will be converted to units. So this is the vector unit of the problem, and that's it. Thank you.